across the term which is known as radius of gyration, denoted by capital K, right? We'll try to understand first what is that. Just now we had, say, different masses, particle, which are at a distance, different perpendicular distance, right? Suppose we are having the masses like M1 here, and we take a rotational axis somewhere. Say I'm taking here my rotational axis. I want to assess I for M1. This is R1. I'm taking another particle. We are having M2 somewhere here, right? And call this is my R2, right? We are having another one, say M3 here, right? And I call this as R3. These are the particles. So everyone is rotating about this axis in a circular path like this, in the horizontal circular path like this, right? That is what it is happening. So in that case, moment of inertia, if I am writing, what will be writing? Can you tell me? I will be what? Yeah, M1 R1
Yeah,
whole
M
square
R1 whole
plus
square.
M2 R2 whole square plus one more is there, so M3 R3 whole square. Am I right? Can we write like this? Okay.
Yes,
Now
sir.
radius of gyration says that if it is such a distance, radius of gyration is such a M1, M2, and M3 at the same distance, correct? At the same distance, this M1, M2, and M3, you keep it, then that is such that it gives the same moment of inertia, right? As this fellow is giving at their own place. Are you getting? M1, M2, and M3 are at a distance of R1, R2, and R3, perpendicular distance from the rotational axis. And then radius of gyration is such a distance in between somewhere it may be, right? Where if I keep them, these masses will get the same moment of inertia I, which we got it here. Clear? So what I'll be doing, I have to just keep them at the same distance, right? So, okay, what I'll do, I'll draw another figure, same rotational axis, correct? And then what I'm doing, all the M1, M2, and M3, M1, M2, M3, I'm keeping at the same distance. Now we are having this as a mass, correct? All are at the same distance, correct? They are now same distance. That distance is radius of gyration. That distance is your K. It will give, if you, it K says that it will give you the same I as we are getting above in the above figure, right? You can check it. Whatever I we are getting here, same I we will be getting here. If I am keeping all the three masses at the same distance, that distance is radius of gyration. So in that case, if I try to understand, I'll be writing my I will be equal to how much? The second case, my I will be equal to your M1 K square plus M2 K square plus M3 K square. All are at the same distance. So yes, it will be your M1 plus M2 plus M3 K square. Got it? This is what we are going to have because I is same, right? I can equate these two. Yes or no? Interesting. Since I is same, therefore we can say from 1 and 2, from the basic definition of radius of gyration, well, I can say that my M1, M2 plus M3 into K M1 R1 square plus M2 R2 square plus M3 R3 square. Correct. So, well, I can say my K is equal to my k will be, you check it, square root of m1 r1 square plus m2 r2 square plus m3 r3 square, right, divided by your m1 plus m2 plus m3. This is the way we can have my radius of gyration. How we can define it now? How we can define it?